the peaceful, flat farmland of Washington State. But after hundreds of miles, it changes. And in the distance, a very different landscape appears. Gorges, some almost 1,000 feet deep. A waterfall, 5 times wider than Niagara, but without any water. Weird holes in the valley floors. Strange layers of silt and ash. And over the whole area, huge boulders are scattered, as if a giant had dropped them there. Few places on Earth are as mysterious and controversial as the channeled scablands that lie just 200 miles east of Seattle. For over a century, scientists have been struggling to explain what forces could shape this unique place. But for much of that time, they were unable to account for it.
When we see a landform or a group of landforms, we rely upon our knowledge as to how similar landforms were created. So the geologist is always thinking of the origin of a particular feature. However, there was one landscape that really defied the understanding of geologists, and of course that landscape was the channeled scabland.
Then a series of clues began to fit together to finally explain this bizarre landscape. And it came about from the study of rocks.
In geology, we are really looking for evidence, for features in the rocks, on the landscape. It's very similar to what a detective does, looking for clues at a crime scene. And those clues are fit into a pattern, and ultimately a culprit is associated with that crime scene.
It's wonderful to be flying over one of the most interesting parts of the United States. Even the first explorers and first settlers who came in this area recognized this as truly remarkable topography. And they realized that this was something like the earth having been subjected to wounds and sores. So they called this scabland. But you can't really get a sense of the scale of this unless you get out onto the landscape yourself.
For a long time, it was assumed that the scabland's features would have taken millions of years to create. One obvious way this could have happened was by the gradual erosion caused by rivers. After all, some of the most dramatic landscapes in the world have been scoured out by rivers.
A lot of the features in this valley do appear at first sight to be related to rivers that may have come through the valley.
But some features require fast and violent river action, while others, like this huge hill of gravel, appear to have been laid down by large, slow-moving rivers over millions of years. And these mysterious layers look like the result of a giant river flooding again and again.
And that's actually really what's been puzzling geologists. How could a river have deposited those features and yet carved out such a wide and deep and long and sheer canyon?
The rivers and lakes in the Scablands today could not have sculpted this landscape. This water is part of a modern irrigation system and was not here when the Scablands were created. The only river big enough and old enough is the Columbia, which is 50 miles away, and there is no evidence it ever flowed through the Scablands. But there's another reason to rule rivers out. No river in the world can form what you are about to see. You will not find these anywhere else on Earth. These enormous potholes are one of the strangest geological features on the planet.
If I was on the bottom of a big river like the Columbia, I might find some potholes that were maybe a few feet across, a few feet deep. But this feature, this rock basin, of which there are hundreds in the channeled Scabland, is about 10 times as big as the potholes that we find in even a large river like the Columbia. It's very clear just from the size of the feature that this was not made by normal river processes.
This revelation turned the Scablands into one of the most perplexing geological mysteries. But if not rivers, then what formed this landscape? Boulders like this one pointed toward another possible culprit. How could this 100-ton giant have been dumped on the edge of this 1,000-foot precipice? It's made of granite, and granite is not native to the Scablands. But granite boulders of many different sizes are scattered erratically throughout the area. Indeed, they are known as erratics. There is one force on Earth that can put this boulder up here, and it is not a river. It is something else. Ice. Ice can carve through solid rock and can help build mountains. "20,000 years ago, during the last ice age, massive sheets of slow-moving ice called glaciers pushed gradually down from Canada towards the Scablands. Glaciers move down valleys, carving out new landscapes as they go. They rip out rocks from the valley floor, and these erratics then travel within the ice, sometimes for hundreds of miles, until they're left behind when the ice melts. But erratics were not the only clues pointing to glaciers. When a glacier carves out a canyon, it cuts through lots of little valleys on either side, leaving them hanging far above the main valley floor.
There are some classic glacial-like features. On the ridge, on the horizon, there are hanging valleys where the cliff cuts a depression. In glaciation, the glacier enters a valley, it enlarges it, and it cuts off the tributaries, leaving them hanging. So it was natural to have as the hypothesis that glaciation may be the origin of some of these large features in the channeled scabland.
Yet again, it looked as if the culprit had been found. Surely glaciers, working over thousands of years, must have created this strange landscape. But there was a problem. The ice sheets that flowed down from Canada during the last ice age never reached the scablands. So the two main theories to explain the gradual formation of this landscape just didn't work. River erosion could not explain giant potholes, and ice was too remote from the scablands to create these hanging valleys. Geologists, it seemed, were back where they had started. Each time they attempted to explain the riddle of this tantalizing landscape, they failed. There was, however, one last theory that claimed to offer an answer. Unfortunately, it struck those who first heard it as completely outrageous. During the 1920s, a geologist named J. Harlan Bretz outlined a theory of what he thought had really happened to the scablands. But Bretz's theory defied all scientific convention. He claimed the scablands were not the result of a slow geological evolution, but of an enormous catastrophe that had happened almost overnight. For years, Bretz traveled the scablands examining the landscape. Eventually, one feature would clinch his argument, although it would take him decades to recognize it. From ground level, these shapes don't make much sense.
Bretz must have walked over thousands of those things, but they're so big in the field he had no idea what they were. He didn't guess what they were.
Bretz would not see aerial photographs of these hills for many years. But we can see from the air how these shapes begin to look like ripples. A giant version of the ripples left behind on the beach by the sea. Even without this key observation, the years Bretz spent patiently examining rocks and other features of the scablands convinced him only a vast volume of water could account for all the evidence. In his mind, the entire landscape, which had once been a flat plateau, was created in a single giant flood. But as Bretz well knew, his geological colleagues, understanding that the Earth was billions of years old, firmly believed that landscapes such as the scablands must have gradually formed over long periods of time. It was this orthodox view that Bretz now seemed to be
Since the 1820s, geologists had come to think on good evidence that most landforms and most deposits on Earth had formed over long periods of time by ordinary processes of rivers and ocean waves and what have you. Bretz comes and offers this immense catastrophe, altering the landscape essentially overnight. And it just didn't square with the way geology had been put together at the time.
On the 12th of January, 1927, Bretz prepared to address a specially convened meeting of fellow scientists in Washington, D.C. This was his big chance to sell his outlandish theory.
The 423rd meeting of the Geological Society of Washington is now called to order.
Bretz was proposing something completely unheard of. A body of water up to 900 feet deep, raging through the scablands, and then flowing off into the Pacific Ocean.
Over 500 cubic miles of water, great flow depths. Now, no gradual process is responsible for this landscape. I am forced by the field evidence, by what I have observed with my own eyes, to come to this hypothesis.
It is clear from my field evidence that the Columbia River, swollen inside, could easily have cut dry falls and deposited...
To any self-respecting geologist, this sounded too much like a biblical flood. They dismissed Bretz out of hand.
This did not happen overnight, but over many thousands of years. To suggest otherwise is ludicrous.
The implication was very clearly that Bretz was committing a kind of heresy and that he should listen to these elder statesmen of the science and rethink his hypothesis.
Even if you were convinced by his unbelievable idea, Bretz still had a problem.
Where did the water come from? And Bretz can't tell them where the water came from. It's one of the big problems with the whole idea.
To convince his colleagues, Bretz needed a source. How could so much water, traveling at ferocious speeds, suddenly appear out of thin air? No one among the top geologists gathered that day could imagine a source for this heretical flood. Well, almost no one.
Sitting in the audience is J.T. Pardee. Pardee supposedly leans over to a colleague and says,
I know where Bretz's water came from.
That this formation...
But it would be more than a decade before Pardee revealed his secret. During that time, Bretz remained firmly in the geological wilderness. But Bretz would not give up, and his theory would eventually return again to take the world of geology by storm. This is Missoula, Montana. It lies 250 miles east of the Scablands. Few who live here would ever suspect that this peaceful place was once the center of an epic confrontation between water and ice. The sheer scale of this confrontation is hard to imagine, but evidence of its true extent lies scattered on hillsides for miles around. For a long time, no one could work out what made these marks. It was only when geologists discovered some scrapings on a rock that an unusual idea unexpectedly emerged.
These marks, scratches as it were, on the bedrock represent the erosion of a large glacier that moved into this valley.
This evidence gave rise to the possibility that the glacier created a lake by damming a river. These watermarks were formed by the waves of this lake splashing against the shoreline of these hills. This glacier came from Canada during the last ice age to reach what is now Idaho.
Looking at a larger scale, the ice moved down the valley from Canada and filled this whole valley from one side to another. It ran into the mountain in front of us and thus blocked the river valley off to the left.
The Clark Fork River, which still runs through this valley, confronted a wall of ice that was at least half a mile high and an amazing 23 miles wide. The river began to back up against this wall of ice and fill the valley with water. Eventually, the lake of trapped water grew bigger than Lakes Erie and Ontario combined. It was this lake that made these watermarks, and if it were still here today, it would drown Missoula, Montana, in well over 1,000 feet of water. The volume of water backed up behind the ice was vast, an astounding 520 cubic miles of water that became known to geologists as Glacial Lake Missoula. This valley was once the bottom of Glacial Lake Missoula, and it holds vital clues to solving the mystery of the Scablands. But what could it have to do with a place that's 250 miles away? It was here in this valley that Joseph T. Pardee, the man who didn't speak up at Bretz's meeting, made an important discovery. He knew from the watermarks that there was once an enormous lake here, but there was no evidence that it had ever been anything but static, until he noticed these ripples.
Those are huge ripples, like ripples on the floor of a stream, but here, instead of being inches high, they're 10, 20, 30, 40 feet high and spaced 200, 300 feet apart. They're enormous.
It was when he saw these ripples that Pardee came up with his own extraordinary theory. He proposed that Lake Missoula had somehow emptied, and as it poured out, the lake water pushed up the gravel on the valley floor to create these giant ripples.
And he looks around and sees these other things that goes with it. There's that great bar of gravel with a steep front to it. There's the pass up there that is sharply eroded. There are these rocks all over the ripples that indicate high speed of current.
And there was something else about the ripples that Pardee noticed. They seemed to point straight towards the Scablands.
Here is a huge body of water, and it's discharging at a fantastic rate, headed right towards Bretz's Channel Scabland.
Pardee's discovery of the ripples was crucial. At last, he'd come up with a possible source for Bretz's giant flood. But there was one question he and his colleagues couldn't answer. What caused the lake to empty in the first place? Vital clues would eventually come from 3,000 miles away, in another extraordinary landscape. This is Iceland. One of the world's most geologically active land masses, constantly rocked by earthquakes and volcanic activity. This island, on the northwestern tip of Europe, is home to strange lava-filled formations, and it also has more glaciers than all of those in Europe put together. Matthew Roberts' work examining glaciers for the Icelandic Meteorological Office has cast a whole new light on glacial Lake Missoula and its disappearing water. What you are looking at now is a modern-day wall of ice. It is the head of a glacier, a smaller version of the one that created Lake Missoula over 15,000 years ago.
This glacier is massive. It's about 300 feet thick, but that's tiny in comparison to the glacier that formed Glacial Lake Missoula, which was at least 10 times thicker. In this example here, the ice has flowed across the valley to the other side, forming a plug. This is exactly the same setting as what would have occurred at Glacial Lake Missoula.
When glacial ice blocks the flow of a river and water builds up behind the ice, scientists call it an ice dam. From his work studying ice dams here, Matthew Roberts and his colleagues have come up with an extraordinary explanation for how Glacial Lake Missoula might have emptied. It has to do with what goes on deep inside these enormous mountains of ice. His theory is based on data from seismometers which monitor tiny ice cracks opening hundreds of feet deep inside this massive glacier.
These cracks signify that the glacier is behaving in a brittle manner, that the ice is fracturing. Just like the fractures that we see behind us here, these crevasses have opened up due to stresses inside the ice, and the crack is heard by the seismometers.
Matthew Roberts was driven to do this work not by an interest in Lake Missoula, but by an urgent need to understand a disaster that happened on his own doorstep. In 1996, a wall of water cascaded through southern Iceland, causing incredible devastation. It was the result of an ice dam collapsing. After years of analysis, Matthew eventually worked out the process that caused the dam to fail. Normally, water freezes at 0 degrees centigrade and forms ice. But deep at the base of an ice dam, the sheer amount of pressure stops the water molecules from expanding. If they cannot expand, then the water cannot freeze. This results in what is known as supercooled water, which can stay liquid at several degrees below freezing. Then this highly pressurized supercooled water begins to force its way into tiny cracks in the ice. Water under this much pressure behaves in some very unexpected ways, especially in such intimate contact with ice. This is the first small step in a chain of events that can end in cataclysm. Once supercooled water has begun to trickle through these cracks, the flowing water alone is enough to trigger a very peculiar process. This moving water creates tiny amounts of friction. This friction releases energy in the form of heat. As the water moves through the glacier, it melts the ice. Soon, minute cracks can become giant ones, several feet across.
More water can escape, the tunnel enlarges very quickly, but then suddenly the dam would have failed, and bang, the whole dam would have collapsed, and a massive wall of water, kilometers wide, would have swept down valley.
This process caused the 1996 Icelandic flood, and scientists now believe it was responsible for what happened thousands of years ago at glacial Lake Missoula, when a half-mile-high wall of ice suddenly collapsed, allowing the entire lake to empty. From these new findings, we can reconstruct just how glacial Lake Missoula sent 2.5 trillion tons of water, nearly half of Lake Michigan, surging across the American Northwest. First, river water built up for years behind the ice dam. Then, as it reached depths of several thousand feet, the pressure grew, forcing molecules of supercooled water into cracks at the base of the glacial Lake Missoula ice dam. What started as a minute trickle of water quickly hollowed out a series of tunnels in the ice that fatally destabilized the whole structure. Then, as the sheer weight of water became too much, the ice dam literally exploded. Leaving a gaping hole, a mile or more wide, through which a sea of lake water erupted.
You would have heard this tremendous roar coming long before you saw anything. The earth would have shook.
Imagine the loudest noise you've ever heard, and multiply that by 1,000 times.
The sheer speed and volume of this incredible mass of water churned up those huge ripples and left behind watermarks as a record of its vast size. This one cataclysmic event sent trillions of gallons of water at ferocious speeds towards the Scablands. This is how scientists believe the ice dam collapsed and how glacial Lake Missoula emptied. But could this single event have created all the extraordinary features in the Scablands? How could a rushing mass of water create canyons that look as if they were eroded over millions of years? Like this one, known as Dry Falls, 20 times the size of Niagara Falls. How could water transport these giant erratics that are normally carved out by glaciers? And how could it form these strange potholes found here on such a monumental scale? To test whether a single flood coming from Lake Missoula could really have done all this, scientists have built their own mini Scablands. Here, the Earth Surface Dynamics team at the University of Minnesota has constructed a scale model of the Scablands and poured water over it to represent the failure of glacial Lake Missoula.
Here it comes.
The rushing water doesn't simply disperse over a wide area. It gouges out channels and then erodes them into extraordinary shapes. It is only when the water is turned off that the significance of these shapes becomes clear.
We're seeing the same essential set of processes. In fact, it's one of the remarkable things about these natural systems is that the same fundamental sets of processes can occur across a very wide range of scales. They're what we call scale independent.
For years, scientists argued that the features of the scablands could not have been formed overnight. But this model clearly shows miniature versions of the canyons found in the scablands. Just like the real ones, they look as if they were gradually eroded. In fact, they were carved out in seconds. But can the scientists also show how these strange potholes were made? This water tunnel demonstrates the effects of water moving at high speeds. An object in the tunnel represents a hard outcrop of rock. At first, the water flows around the object without any apparent effect. But then they turn up the speed. A stream of minute bubbles appears. When those bubbles burst, they burst with immense force against the object. As the speed of water increases further, the bubbles collapse with ever greater intensity. The process, slowed down nearly 100 times, reveals a long twisting thread emerging from the metal object. It is in this high-speed vortex of bubbles where the secret to the flood's incredible power lies.
So if you look at this, the first thing we see here is this very strong vortex here. So you got like a sledgehammer effect. Every time one of these forms and collapses, bang, you've got a sledgehammer.
So could bubbles really gouge holes out of solid rock to resemble the potholes in the scablands? Slowed down 80 times, this experiment shows solid rock being drilled out by the power of bubbles. But what would this have looked like during the flood? As the flow of water from Lake Missoula surged through the scablands, it would have hit some hard outcrops of rock, creating a vortex of bubbles. Within seconds, these bubbles would drill through cracks in the rock, and the turbulent currents would then scour out huge potholes. With this last mystery solved, it does seem plausible that a single giant body of water could create all the features of the scablands. So it is now possible to complete the reconstruction of the incredible events that took place on a fateful day 15,000 years ago. The immense pressure of supercooled water fatally destabilized the ice dam at glacial Lake Missoula. Then massive chunks of ice within the dam began to fall into the raging torrent until the whole dam just gave way. collapse of the ice dam released a sea of water. This water then traveled up to 60 miles per hour, rushing headlong towards the Scablands. It took only a few hours for the water to reach this once flat landscape. In places, the water was a staggering 800 feet deep. As this volatile torrent flowed ever more quickly, it gouged out miles of rock. It carved out cliffs and canyons, including the massive feature that is known today as Dry Falls. Meanwhile, huge underwater tornadoes were blasting out potholes. The bubbles that formed these tornadoes imploding with enormous force and penetrating deep into the bedrock below. As the chunks of ice from the original glacier were carried huge distances by the floodwaters, the boulders they contained within were randomly flung aside. When the floodwaters receded and the icebergs melted, they would reappear scattered all over the Scabland. After a tumultuous journey, this muddy torrent surged out to sea along the floor of the Pacific until it came grinding to a halt over 1,000 miles from its point of origin. It had only taken a few hours to get there. "80 years ago, J. Harlan Bretz shocked the geological establishment with an idea that was seen as heresy. But over the years, more and more scientists gradually began to accept his theory.
Oh, I think Bretz was absolutely delighted to see the vindication of his ideas. I think it all culminated in 1980 when he received the highest medal of the Geological Society of America, the Penrose Medal, which was the final and ultimate recognition that he, in his catastrophic flood hypothesis, had generated one of the great ideas in the earth sciences.
It was left to later generations of geologists to work out the details of how the giant flood had happened. Their research not only confirmed Bretz's outrageous hypothesis, but has recently revealed that, if anything, Bretz was not outrageous enough. For there may have been more than one giant flood. This final twist in the tale centers on one of the classic features of the Scablands that has long intrigued geologists. This canyon with its many layered deposits. Richard Waite has been studying these deposits for over 20 years. It was assumed that these layers were formed by changes in the speed of one giant flood, known as pulses. But that was before he discovered something odd, a white line within the sediments.
This is what caught my eye first time down in the canyon. It's an ash layer from Mount St. Helens. We've analyzed it. Once you become familiar with these ash layers, they become old friends, so I knew what this was. It's an ash layer from Mount St. Helens. It's about 15,000 years old.
Mount St. Helens in Washington state erupts regularly. The ash from the eruption can spread over thousands of square miles, as it did some 15,000 years ago near the time of the Scablands flood. At first, it was thought that the ash had fallen into the water and drifted down into these layers. But could a layer of ash really sink through hundreds of feet of turbulent floodwater to form this amazingly neat, clear line?
This whole column would be full of mud and sand and silt, and to have something settle through it and come out like this is impossible.
This suggested something completely new. That all these layers weren't laid down together.
It's clear evidence that periodically during the accumulation of this sediment that there had to been dry land.
And the implication of that is that there wasn't just one giant flood. Perhaps there were many. After one super flood swept through the scablands, the floodwaters drained, and there was a period when the land was dry. It was then the ash fell, before another super flood hit and laid more deposits on top. The only way to know whether this theory is true is to date the layers, as Kathleen Nichol is now painstakingly doing.
This is a really thick sequence of rocks, and by looking at the age of the bottommost unit that we can sample, and then the topmost unit, we'll be able to see if it's one great big flood that stacked up a lot of sediment, or whether it was a series of floods coming in every few years, perhaps, over many thousands of years.
It will be years before Kathleen has dated every layer, but her first results show that the top and the bottom layers of the canyon are 20,000 years apart.
We thought that there was just one flood.
But now, with these results, we can say with certainty that this area has been repeatedly hit by cataclysmic megafloods again and again.
With these latest results, the culmination of over a century of geological investigation, it now seems that gigantic floods, as well as smaller ones, were a regular feature of this landscape during the Ice Age. Incredibly, ice dams collapsed and reformed in a cycle that rocked the scablands again and again. Despite the conflict between a catastrophic view of the scablands and the standard view of gentle, continuous change, we now know the truth is somewhere in between. There were huge catastrophes that carved out these giant landscape features, but they were part of a cycle of floods that repeatedly swept through this landscape.
The channeled scabland is one of the most fascinating landscapes, and the tremendous catastrophic floods were probably the most spectacular things that happened on the planet. This legacy is part of human history, and I think that it's just an exciting scientific problem.
On NOVA's website, explore the giant potholes, granite boulders, and rippled ground of the scablands for yourself, and trace how experts unraveled the mystery of the megaflood. Find it on pbs.org. To order this show or any other NOVA program for $19.95 plus shipping and handling, call WGBH Boston Video at 1-800-255-9424. Nova is a production of WGBH Boston.